Given an infinite geometric series, find its sum. First thing we do is identify the first term in the common ratio. We need to confirm that the common ratio r is in between -1 and 1, and if so, then we can substitute the values of the first term in the common ratio into the formula to find s. So, example 7, finding the sum of an infinite geometric series. Find the sum if it exists for the following. For part A, we have 10 plus 9 plus 8 plus 7. If we take 9 and divide it by 10, that gives us a common ratio here, or it gives us a value of 0.9. If we take 8 and divide it by 9, it gives us 0.8 repeating. These are not the same. There is not a constant ratio, so the series is not geometric. Now, if we take a look at the next series, we have 248.6 plus 99.44 plus 39.776. Well, first, let's check and see if the common ratio exists. Okay, so using our calculator, we have 99.44, and we're going to divide that by 248.6, and that gives us 0.4. If we take 39.776, which is the third term, and divide it by the second term, 99.4, that also gives us 0.4. So, there is a constant ratio. The series is geometric, so we have the first term of 248.6. The common ratio is 0.4, so the sum exists. So we're going to substitute those values into the formula and simplify to find the sum. So here's our formula. And we have the first term, which is 248.6, divided by 1 minus 0.4, which equals 414.3, with the number 0.3 repeating. Let's take a look at C. Well, in C, we can see that it is a geometric series because we have an exponential function. So the value of r is -1/3. Since the formula is exponential, the series is geometric with r is equal to -1/3. But then we need to find out what is the first term by substituting the value of 1 into the formula. So by substituting k is equal to 1 to the given formula, a subscript 1 is going to equal 4,374 times -1/3 raised to the power of 1 minus 1. Well, 1 minus 1 is 0. And so -1/3 raised to the 0 power is 1, and 1 times 4,374 is 4,374. So now we've determined that the first term is 4,374, and the value of r, the common ratio, is -1/3, and we're going to substitute it into the formula to find the sum. So s is going to equal 4,374 divided by 1 minus -1/3, which gives us 3,280.5. Okay, the last one, part D, well, we can see that the formula is exponential. And so the value of the common ratio is 4/3. R is equal to 4/3, so it's exponential, which means that the series is geometric, but the value of 4/3 is greater than 1. It doesn't fall within that range of -1 and 1. And therefore the sum does not exist.